Data values can be in one of three data types: numeric, string, and Boolean, also known as logical data type. This challenge focuses on the numeric data type. Numeric values are real numbers like 0, 3.14, 1 million, -40, and -273.15. I've used numeric expressions in earlier challenges, for example, converting between kilometers and miles. I'll go to Data and create a couple variables. I'll create miles, and I'll create kilometers, which I'll abbreviate as km. Kilometers is equal to miles times 1.6. I'll also want to set miles. I'll select miles, make that 1. For the expression for kilometers, I'll need miles. I'll go to operators, multiply, miles times 1.6. I'll get the green flag event handler, and the program will be ready to run. I'll move miles and kilometer into the center. Click on the green flag. When miles is 1, kilometers is 1.6. That's good. I'll try another value. I'll try miles of 5. Run it. I get kilometers as 8. So it's acting correctly. I can convert from kilometers to miles. I'll duplicate this code. I'll start with kilometers. I'll set kilometers to 1.6. I want to set miles. I'll change miles to kilometers, and I'll change multiply to divide. Miles is equal to kilometers divided by 1.6. I'll run it. For 1.6 kilometers, I get 1 mile. I'll change 1.6 kilometers to 8. Run it. I get 5 miles. Numeric expressions can be combined, like when converting between Fahrenheit and Celsius. I'll clean this up a little bit and reuse some of it. I'll go to Data, get kilometers and miles off the stage, and I'll create another variable. I'll create Fahrenheit, and I'll create Celsius. Celsius is equal to the quantity of Fahrenheit minus 32 divided by 1.8. To convert from Fahrenheit to Celsius, I first have to subtract 32 from Fahrenheit. I'll get Fahrenheit and operators. Fahrenheit minus 32, and divide that by 1.8. Change the 6 to an 8. Move it into the second set. I'll change the first one to Fahrenheit, the second one to Celsius. I'll clean that up. I'll set Fahrenheit to 32. Move Fahrenheit and Celsius into the middle. I'll run the program. Fahrenheit of 32 is Celsius 0. 32 degrees Fahrenheit is 0 degrees Celsius. I'll change Fahrenheit to 212, which is the boiling point for water. Run it. I get Celsius of 100 degrees. One more value. I'll try Fahrenheit at minus 40. Minus 40 degrees is the same for Celsius and Fahrenheit. I'll run it. And I have negative 40 for both Celsius and Fahrenheit. I can also convert from Celsius to Fahrenheit. I'll reuse this code, copy it, move that out of the way a little bit. I'll set Celsius to 0. I want to set Fahrenheit. I'll break this out. I want to multiply Celsius, right-click, change it to Celsius. Right-click on the division, change it to multiply. I want to multiply Celsius by 1.8. Then I want to add 32 degrees. I'll change the minus to plus. Now I'll run the program. 0 degrees Celsius gives me 32 degrees Fahrenheit. I'll change Celsius to 100, boiling point, and I'll run it. I get 212 degrees Fahrenheit. I'll change Celsius one last time to negative 40 degrees. Run it. I get negative 40 degrees for Fahrenheit. I can compute the circumference and the area of a circle given its radius. I'll go to Data, Celsius and Fahrenheit, get rid of the extra set of commands, and I'll create some variables. I'll create pi. I'll create the radius variable. I'll create area. And I'll create circumference. I'll move them into the middle of the stage. And I'll break this command off. Change Celsius to pi. And the value is 3.14159. I also want to set the radius. I'll duplicate. Pull down radius. I'll set radius to 1 for the first test. Then I want to set the circumference. Break this off. I'll get rid of the addition. Duplicate. Circumference is equal to 2 times pi times the radius. Drop that in. Circumference is equal to 2 times pi times the radius. I'll attach it. I'll reuse this set to make the area. Area is equal to pi times radius squared. Area is equal to pi times radius. Program's ready to run. I'll click on the green flag. With a radius of 1, I get twice pi for the circumference, and the area is pi. That looks correct. I'll change radius to 10, so the number should be 10 times larger. Click on the green flag. Radius is 10, circumference is 62, and area is larger at 314. The values look correct. Scientific notation is available for those who understand it. I'll show it briefly, but don't worry if you don't understand it. It's not necessary to using Scratch. It's a convenience. The speed of light in a vacuum, known as c, is approximately 186,000 miles per second, for 3 digits of accuracy. In scientific notation, 186,000 is 1.86 times 10 to the 5th. If you multiply 1.86 by 10 5 times, 2, 3, 4, 5, you get 186,000. To set a variable to 186,000 using scientific notation in Scratch, you can assign the variable the value 1.86e5, where e refers to the exponent for the base 10, and 5 is the number of that exponent. For example, initializing c to 1.86e5 is the same as initializing it with 186,000. I'll go back to the program and try it. I'll create the variable c for the speed of light. And I'll set it to 1.86e 10 to the power of 5 e5. I'll get the equals operator, and I'll compare c to 186,000. Go to Data, get c. I'll start the program. Not that this is attached to it. I'll click on Set. C is now 1.86e5. When I click on the equals expression, I get true. For my next example, I want to randomly select backdrops for the stage 8 times. I'll get rid of these variables off of the stage, and I'll clean up all the commands. I'll get a couple new backdrops. Go to New Backdrop, scroll down, select stage 1, get another backdrop, scroll down, select stage 2, I'll go to scripts. The scripts are gone. The scripts are gone because I have the stages scripts. I want the cat's scripts. Click on the cat sprite. I can see that the cat scripts still exist, but for this example, I'll use the stages scripts area. I'll bring the cat down onto the stage and reselect the stages scripts. To switch backdrops, I'll go to looks. There are fewer looks commands for the stage, but that's understandable since it's not a sprite. I'll select switch backdrop and wait. Switch backdrop will change the backdrop on the stage. I can select the different backdrop names. I can also select them by number. If I go back to backdrops, I see that each of the backdrops has its own number, 1, 2, 3. I'll go back to scripts. I'll choose operators. I want the program to randomly pick a backdrop. I'll use pick random. I only have 3 backdrops, so I'll change the 10 to a 3. Pick random will generate a random integer between 1 and 3, so it'll generate 1, 2, or 3. I'll click on it a few times. 1, 2, 1, 2, and there's 3. I'll drop it into switch backdrop, go to control, get a repeat loop, change the 10 to an 8, events, green flag is clicked, go back to control and add a wait so this doesn't go too fast. The wait here is only making sure that the backdrop is visible. It's not waiting for a specific time like the wait command. Program's ready to run. When I click on the green flag for 8 times, it will switch the backdrop to a randomly selected backdrop, which may be the same backdrop that was currently being displayed, and wait for a second. So I'll click on a green flag and the program will run in 8 seconds. There's 1, 2, 3, 4, 5, 6, 7, 8. This example's working. I'll go back to operators and look at some more numeric operators. I'll use the round operator. I'll click on block help to get some more information about round. Round gives the value of the integer closest to the number. Scratch has a couple examples here. Round to 5.1 is 5. Round to 5.6 is 6. I'll get rid of the help. Try a couple different values. Try 4.4. Round to 4.4 is 4. Round of 4.5 is 5. And round of 4.6 is also 5. Finished with round. I'll get the function operator. The function operator has a list of functions that are available. Many of these functions are related to higher mathematics, including trigonometry, so I won't talk about them here. But I will look at 3 of these. Absolute. Absolute returns the magnitude of the number. If the number is negative, it returns the positive value. For a few quick examples, absolute value of 9 is 9. Absolute value of 0 is 0. Absolute value of -1 is positive 1. Sometimes an integer value is needed for a real number, a number with a fractional part like 1.3 or -2.4. Scratch has 2 functions to make integer values from real numbers, floor and ceiling. Floor returns the closest smaller integer value for a number. The integer is to the left on the number line. Ceiling returns the closest larger integer value for a number. The integer is to the right on the number line. I'll show this on a number line. Various numbers can be found on the number line. 2.7, 1.3, 1, -2.4. For the number 2.7, the floor of 2.7 is 2. 2 is the closest smaller integer value. The ceiling for 2.7 is 3. 3 is the closest integer value larger than 2.7. The floor value for 1.3 is 1. 1 is the closest integer value less than 1.3. The ceiling for 1.3 is 2. 2 is the closest integer value larger than 1.3. The floor and ceiling values for 1 are 1. 1 is already an integer value. The ceiling for negative 2.4 is negative 2. Negative 2 is the closest integer value greater than negative 2.4. The floor for negative 2.4 is negative 3. Negative 3 is the closest integer value less than negative 2.4. I'll go back to the program now and show these values. The floor of 2.7 is 2. The ceiling of 2.7 is 3. The ceiling of 1.3 is 2. The floor of 1.3 is 1. The floor of 1 is 1. The ceiling of 1 is 1. The ceiling of negative 2.4 is negative 2. The floor of negative 2.4 is negative 3. Scratch has various trigonometric and algebraic functions available. I'll use some of them in an advanced challenge later on for those familiar with them to show how easy they are to use and how powerful they are. I'll discuss the mod operator in a future challenge. It needs its own challenge. I'm finished with this example and this challenge now. I want to encourage you to use the examples and get experience using numeric expressions. Play with the different operators you've just seen. Try creating more formulas like converting feet to inches or miles to feet or yards. Try changing the program that randomly selects backdrops to randomly display more backdrops. Or for a harder challenge, try changing that same program to not use the last used backdrop, so the backdrop will appear to always change on the stage each second. But above all, have fun with the challenge.